Okay, we are now live. And hopefully everybody can see all right. All right, so if you guys haven't grabbed it, there's a bunch in the cooler there. So for any of you that are walking in, straggling in late, grab a beer and a seat. There's a couple, if we're running out of seats too, there's tons on the side. We can pull out more of the cubes. So we'll kind of get rolling. Hopefully not take up too much time because it's pretty nice out today. I'm Eric. There's David. We run the JavaScript group here. And we're giving a talk, or I guess I'm giving a talk this time on using React. So this is going to be kind of an intro talk to React and Flux, and then a little bit of, I guess, some stuff that I've learned over the last 10, 11 months using it, both with a big organization, KISS Metrics, and then on some smaller projects and doing stuff on with Electron, with building kind of cross-platform native apps too. All right, so our sponsors here: Assembly, where you're at, Startup Calgary, Village Brewery, and Petrifeed. If you want to fire them a tweet for sponsoring the beer, that'd be awesome. And Assembly for sponsoring the space. So for those of you that have been here before, they have a co-working space downstairs. If you're looking for space, it's a wicked spot. Lots of amenities here and a great group of people, like-minded entrepreneurs. So really wicked spot to hang out. And they're nice enough to give us the space here, which is sweet. So last month, Christian, who I saw wander in somewhere, he gave a wicked talk on ArangoDB and gave a nice little overview. Again, all that stuff is up online, so you can at least go and watch the video up on the YouTube channel if you want to watch it. And then Olivier gave a talk about the Unix philosophy and like how to apply that to JavaScript, but I think it was a little bit more about like just the Unix philosophy in general, how to apply that to your development. I think I quite enjoyed it because there's a little bit, you know, he's obviously a bit opinionated, but there's some really good points that he made there, and I think basically keeping things simple and small and self-contained, and that's kind of a little bit of what we're going to kind of take into this React talk as well. So, React, not another framework. Yeah, so, I mean, there's actually a great group of guys over at the Van.js meetup group, and two friends from Brewhouse, they gave a talk. It might just be up on their blog. But basically, they gave a really good talk about Godfrey. Chan gave a talk, and then oh, no, I'm totally blanking. Gabe Schultz gave another talk on React, and Godfrey gave a talk on Ember, and basically talking about kind of hype fatigue. And there's been a lot of that happening in JavaScript world in general, just because there's been so many new frameworks coming out so often. People kind of making different stabs, but sort of reinventing the wheel. And I think, from my perspective, React was a pretty big step forward. I think they're doing a lot of things right. There's some really weird stuff that threw me off initially. And after watching a lot of talks and spending a lot of time working with it, I've kind of come around to why it's so powerful, why it's actually solving a lot of problems really well, because I've run into some of those problems in production before. And yeah, we'll touch a little bit on that through this lecture. So React isn't actually a framework itself. But what is it then? So it's actually just a view engine. So if you're used to the MVC paradigm model view controller, right, React is kind of the view part of that. But it does a lot more than just rendering stuff. It's not just a templating engine. So React actually gives you a way of defining reusable components. It provides hooks into a lifecycle, which I'll show you in just a second. It gives you a way to manage what I like to call smart components and dumb components. So basically stateful components versus not stateful components, or things that should just render something or just show something and don't have to worry about their own state. It gives you one of the big things, and they didn't necessarily invent it, but they really brought it into the foreground, something that's called virtual DOM diffing. And I'll talk a little bit about that. It's also JSX if you choose to use it, which is kind of a syntax for defining your markup in JavaScript, which is what throws a lot of people off, including myself. I was like, what the hell? And then some additional add-ons for performance stuff, animations, things like that. So the component lifecycle, if you've ever worked with backbone views, for example, you're used to having a render method, and then you kind of had to do your own stuff if you wanted to figure out something before render or after render, or before the view was created or after creation. And so people kind of patched backbone views to support that. And then some of the other frameworks that came along, like Angular, actually kind of deal with some of that for you, kind of behind the scenes. And React does take care of the setup and teardown of your views, but it also gives you hooks into the lifecycle so that you can augment things if you need to. And so these are the series of methods that are available to you. You have get initial state, and I'll talk about state and props and what the difference is. Get default props, so that's kind of setting up your properties or setting up your state. When the component is going to mount, when it did actually mount, so when it was actually fully rendered and kind of created. When it will update, so basically when it will receive new properties. If you've got a parent that owns that component and passes new values to that component, which I'll kind of show a little bit of how that works, that method will get triggered. When the component actually will update, when it did update, its actual render method, which is kind of the core piece of React, and then when it will actually unmount, so when it's going to be destroyed. So the nice thing with that is you don't have to manage any of that stuff yourself, which, especially in Backbone or a bunch of the, I think even with Knockout, managing that stuff yourself really kind of led to, if you didn't do it carefully or if you had really nested views, you could end up with memory leaks by not closing things down properly, and it became really, really messy as applications became more complex and larger. So one of the other big things of React that has kind of been it's one of its claims to fame has been virtual DOM diffing. And the premise behind that is that executing JavaScript is actually faster than manipulating the DOM. So rather than trying to just patch stuff in or rework the DOM or re-render the DOM every time, what we'll actually do is we store a version of the DOM in JavaScript. So we store an exact copy of it with all of its attributes. And we'll actually apply, we'll re-render that. And what we'll do is we'll actually apply that. We'll keep kind of the previous state and the new state. We'll do a difference on them to see what should be applied to the DOM itself. And so that happens every time you've got a new rendering cycle. So every time any of your data or your state changes or any of your properties change. And it seems like it would be really expensive, but it's actually been really, really fast. And the reason being is that executing JavaScript is actually really quick. Manipulating the DOM is really slow, so the amount of changes you need to make to the DOM usually ends up being very minimal versus if you were changing it every time. And so there are actually some other reasons for doing that, and I've included in the slide deck a bunch of references for why, but essentially there's kind of four main reasons why Facebook decided to do this, because it still sounds a little bit insane. Like you're re-rendering every single time the whole DOM, even in JavaScript. It seems like it could be wasteful. And in theory, it actually is pretty wasteful still. Like there's probably room for improvement, and I'm not an expert on this, but from the developer's perspective, it's very easy to understand, because you don't have to worry about whether this information is like which parts are going to change. You just know that when you're looking at your render cycle, whatever is in the render method, whatever data is in there, that's what's going to be rendered. You don't have to worry about whether some of that stuff is going to change or other parts are going to change. It's very easy to kind of visualize what the DOM will look like. Another interesting thing is that they're able to actually apply the differences at smarter intervals. So they're able to do it when memory usage is lower, or when other operations are, well, actually, essentially when memory usage is lower and when CPU is lower. You can also batch stuff too, so they can batch the differences as opposed to just trying to do it one after another. So the algorithm is actually quite complex underneath, which makes it quite a bit faster. And then one of the other big benefits was, because they're using a virtual DOM, they're able to get cross-platform or cross-browser compatibility a lot better, because you're using they've got their own DOM that they can apply events to, and you don't have to worry about whether the IE manages events, or whether certain properties are available on IE versus IE 6 versus IE 8 versus IE 11. They're all the same event structure that Facebook has defined, because they've literally created their own event system as well, which sounds kind of insane because you're reinventing the wheel, but they've actually done a really good job of it. And we might talk about this a little bit in a different lecture, but I actually didn't quite completely get the rationale behind it until they kind of announced React Native. And so you can definitely see, they've been working on this for, I think, over 3 years now internally. They've got internal apps that have been out using this for over a year and a bit. They put a lot of thought into this. They've also screwed up building a web app, like a mobile web app. They've also sort of screwed up building native apps, and then they fixed it by building things like Paper, like some of their libraries that used a lot of the same paradigm. So Facebook has actually gone really kind of all in on the whole paradigm behind Flux and behind React and reusable components, and also on just how data gets passed, and kind of we'll talk a little bit about the unidirectional way that data gets passed around. So, like I said, it seems a little bit insane, but I think for me, I put a lot of trust in that they know a hell of a lot more than I do, collectively at least, for sure. They've learned a lot more lessons than I've learned, and I think they're doing it really the right way, and they're really, their whole ecosystem, their whole open source ecosystem, if you look at it, is kind of following the same trend. So they're really bought into this. It's not so much like, I hate to say like Google, for example, where they seem to have different factions creating different groups. You really see that their whole ecosystem is very, very similar. So again, like what for the virtual DOM diffing? It's a little bit crazy. And then JSX was another thing that's also a little bit crazy. I'm going to quickly pull up. So for example, here we've got stuff like JSX, where you're putting in basically markup. Let me make that a bit bigger. And I'm going to find something a little more exciting. So here we've got, basically this is our JSX. And this ends up, you can write it in JavaScript. It looks pretty shitty. It's actually pretty, it compiles all right because you can still read it, which is fine. but writing it is a little bit tedious. And I find this is much easier to visualize the structure of what that component should look like. And you can see that it's got multiple divs. It's got a couple nested inside of one. It's got a button inside of it. It's a little bit weird, though, in terms of how you kind of, we've kind of always been taught to keep HTML separate from JavaScript and CSS separate from those and separate them all, because the old way of doing it was to put them all together all inline, and that was a total nightmare. And now it almost seems like stuff is actually coming back together. And there are justifications for why, and I'll try and do them justice. But this is kind of the reaction that I had, is like, what? Again. And I think the biggest thing is that the whole point that they're trying to focus on is creating small components, creating stuff that's really self-contained. So the nice thing here is they're showing the types of properties that can be passed in. So it's a little bit, it's pretty declarative, right? A little bit static almost. But you're declaring the types of properties that can be passed into this component that are valid, whether they're required or not. No, you don't have to. This is totally optional. It is nice, though, because the error messages are actually quite good. And it gives you a nice structure to test against. But you have your logic. I mean, here we don't really have any additional logic other than what's in render, which isn't doing too much. We have our markup, and in some cases we could actually have our styles, which I'll kind of show. That's a little bit also crazy. But the reason being is that the way that Facebook is approaching this is that it's easier to reason. So you can see, one, we've got a self-contained component here, but it's also, that is all of your component. Like, unless you're bringing in some external libraries, that might be the case. But generally, this is all of your component. You don't need to think about anything else when you're looking at this, right? You don't need to switch between different files. You don't need to try and look up the template somewhere. You don't need to try and find the styles somewhere. All of it is right there in one spot. The interesting thing, I'll kind of show really quick what you can do with styles. So there's this thing called Radium, but the idea is that basically the way you pass, that you can put properties, or sorry, let me step back. So a React component has attributes. So for a class, they call it class name. A little bit weird, but that's so because class is a reserved word in JavaScript. You can have disabled. It supports a whole bunch of different properties. Styles included. You can do inline styles. And so the rationale behind why you would even think about putting styles in your component is a lot of what I'd already talked about in terms of encapsulation, it all being in one place. And the interesting thing, I didn't buy into this too until I saw the talk on it from the recent React conference. All of the CSS, like kind of pre-processor engines like Less and Stylus and Sass, they've all been kind of reinventing the same stuff you've been able to do with JS for forever. So if you look at all like mix-ins, variables, math, like you can do all of that in JavaScript. Even scoping is still an issue with CSS without shadow DOM or without putting classes. But when you do it inline styled, the scope gets applied right there. So you actually get all of the things that everybody's been trying to do with CSS by just using JavaScript. It's just kind of silly because you're putting it all in JS, and we've been taught to put everything separate. But when you actually look at how they've done this stuff with Radium, my concern was always like, okay, well, that's great. But typically in my Less files, I've got inheritance, for example. Like I might have base styles, and then I've got some specific overrides for a certain type of button. And how would you handle that? So these guys aren't dumb. They've thought of that. And how you can handle it is basically you define your different styles like base or block, right? Your certain classes or your hover effects. And then what you do is you basically pass it in as an array, and order matters. And so that's how you can actually do styles in your component as well. So again, this is totally optional. This you don't have to do. Most people don't actually. But it's a definitely a very interesting way of looking at kind of coming full circle and looking at what we've been taught and kind of coming back to it and going, oh, that actually might make more sense. And where this becomes really interesting is if we do another talk later on React Native, that was kind of the whole point of where, I mean, when you see all these pieces kind of come into play and come together, you can see that they've been thinking about kind of the native play for quite a while. Because a lot of how you do this stuff on React Native is very similar. How you define styles for a native device versus web is very different. But they've basically created this abstraction layer that's actually quite elegant by just using JavaScript to be able to do it on both.
Are you using Radium?
Am I using Radium? No, not yet. Yeah. Yeah, I probably will.
But you don't need to use Radium to use inline styles.
Nope. No, you can put the styles right in there. They're basically, so the inline styles here, we'll go back. Radium's not really doing anything special. The only thing that they're really doing is basically handling arrays and order and overrides. That's the only thing that they're really doing. Because really all this stuff is, and allowing you to nest your object, I guess, all the inline styles are is just an object. So if I were to go and say apply a style to here, I could do style equals whatever my, let's call them styles. And here I might define styles to be an object that looks like height, 400 pixels, width. If I have all of, I can just use any CSS variable that I normally would. Any CSS value.
You don't.
Depends on the attribute, right? So like, I would say probably your best bet is to put in quotes all the time, just so you don't screw it up. But like,
the value.
You don't need to put in quotes?
Yeah, you can just put a 400.
Does it?
Yeah.
Oh, nice. I thought I had run into an issue where it didn't, but that might have just been me making a mistake.
Things like jQuery UI, you'll get into trouble if you do that, just because sometimes it'll assume integer and string things. So if you're specifying like an animation distance or something like that, you specify it in just 400 assume pixels, but you can say
Right.
4 EMs.
Yeah. Yeah.
I don't know if this has the same.
No, I think you're right. If you just pass the value, like you can just pass the value, and I forget what it defaults to. But if, yeah, pixels A. But if you want to actually put the units, then you have to put it in strings. And then obviously, like if you want to do something like min height, right, where we've got a hyphen, you're gonna need to put in quotes.
You can also do the
Right. Yes, you can. And that is one of the interesting quirks with React. I kind of talk about it a little bit later. All right.
Is there any functionality to let you kind of take a hybrid approach where you pass in, say, a CSS string and forces it into a JavaScript object? So I'm just trying to think of ways to like lighten your lock-in Radium if you decide to back out.
I'm not sure. With Radium, I don't know, because I haven't actually used it yet. I mean, and I was just looking at it from the, just using the JS object notation. Yeah, I don't know. That might be an interesting thing, though, to be able to feed that stuff.
Yeah, just this, but is that CSS never actually compiled and put into the transit style sheet, or is it only just on the style attribute?
Just a style
Just
attribute.
style attribute. So
yeah,
you had a whole lot of the same objects with the same styles, it's generating the same stuff. or attaching the same stuff every time.
Look at the Facebook, so it's pretty verbose. It's
Yeah.
actually really freaking verbose.
Yeah.
Even when it throws on the page.
But you still have freedom to like use classes if you want to.
Yes.
Yeah, and I mean that's why. So I mean, I guess to kind of step back, like the stuff with Radium is pretty fresh. Like I only saw it a few days ago. Like I think they've been working on it for a little bit, but most people are using classes still and still using Less or SAS or whatever. And that's currently what I've been using in all of my projects as well. But after watching the talk, it was kind of like a light bulb. I was like, wait, I thought this was stupid, and now I actually take that back. Because I'd be interested to see how it actually scales, but the whole premise, like I said, where these guys are coming from is taking readability over everything, like readability and understandability, and they didn't want to sacrifice performance. So they managed to get performance while still being able to have readable and like nearly immediately understandable code. And I'll kind of come back to that a little bit later, well, like why that's really important. So smart versus dumb components. So like I said, when I talk about a dumb component, that essentially is just a regular view. Like doesn't have any state inside of it. Isn't really. It doesn't. It's just displaying data. It could still be interactive, but it's not manipulating its own state. And what I mean by that is React has the concept of props or properties versus state. And so the idea is that a parent passes in properties into the child component, and then the child component doesn't ever manipulate its own properties. It's a one direction only. State, on the other hand, can be internal or is internal to the component. So you can have a common pattern is for parent component to pass in initial properties, and then you to take those properties and convert them to state inside of that component. And maybe they'll make more sense actually when I show the smart component. So when we look at a dumb component, we have basically the common stuff. We require React. So I'm not using the ES6 syntax, still old school at the moment. You create a class, and we're going to call it a button. So this is React's base level class. This is totally optional, but we're putting prop types. So I can pass in a title, and pass in an on-click handler, right? And so the title has to be a string, and the click handler needs to be a function. And then we've got our common render method. So all I'm doing is rendering this DOM structure. React's going to convert that to JavaScript, and that gets then compiled to, will get rendered out as if it were like a template, and rendered out when this component is rendered. And so we've got our class, and then our on-click handler, and so and the title. And so if you want stuff, whenever you're using JSX, you need to, and you want to use a JavaScript notation. So whether you want to use like the actual click handler or you want to use the actual attribute for the title, you need to wrap it in curly braces. And essentially, this is just a button that when I click it, it's going to call the on-click handler that was passed into it. Nothing special. So then the difference is when I go to a smart component, I'm actually caring about the state. So we'll make this is a special button, it's a toggle button. So we're going to change a class when this button is clicked. So maybe we want to animate it, or we want to highlight it a different color, or we want to show a check mark or whatever, right? But essentially, the major difference is that we've got get initial state, which is setting up that when this component is first initialized, its internal state value, which is referenced by this.state.clicked, right? Whether it's been clicked is false. And this is a nice little helper. I'll come back to that in a second. And then when we click our click handler, I'm sure you guys can see that already. We're going to call our own internal method. Now, kind of the convention has been to prefix private methods with underscore. But what we're going to do is we're going to set our own internal state to say now we're the opposite of what happened. And then we're going to call the on-click handler that was passed in by the parent. So again, nothing too crazy, but the difference here is that I'm actually, by clicking the button is changing its own internal state. So that's kind of the difference between a smart component and a dumb component. Any questions?
Okay.
And so I'm going to just copy this real quick and jump into the console. So another thing that I can do, right? So let's say right now we wanted our parent to actually initialize this button with a certain state. So let's say you got something from the server. Actually, here, let's use this as an example. Like this is a almost imitating a checkbox, but we're using a button. And we want to pre-fill that the user has accepted terms, right? So the state might be that we want this active because the data we got from the server said that the user accepted the terms of agreement. So what we might want to do then is do get default props, and then we might do click this false. So this is basically allowing us to say the props that were passed in, if there weren't any that were passed in, we're going to say that our default state is false. And then what we're going to do is we're going to say our internal state is this.props.clicked. And the way that I would maybe call this component, say we're in a different, maybe I'll jump into a different file. So I would require my button and let me just jump in here. We'll just call this parent for now. And it's not going to do anything special other than return button. And we're going to say that the title is clicking, and the yes, thank you. Click is true. So this is kind of what a parent would look like. Get rid of all this stuff. So that's how you would call, that's how you would call or basically initialize that component, create that component. And so it's a top-down approach in the way that this stuff gets created. You're going to have a root level, which is typically your app, and then you have a bunch of components, which then may have other components, which then may have other components. Any questions? Does that make sense?
Question about the, I'm not sure if it's the initial state of the default props, but do you know if the strategy is merge or clobber? Like if you're missing keys that the parent is passing in and then you have an initial state, does it put the two together? Or
It merges.
It does.
Yeah. But it will. Yeah, it's nothing actually. Sorry, my bad.
Yeah, you could pass in 12,000 properties, and if you're getting initial state, it turns into out. object.
Yeah.
You got this.
Yeah. Yeah.
You have to explicitly copy them over.
Yeah, you have to copy them over. And so there's been mixins created. And I would actually say, like, I don't know, I think a couple people have kind of come out and said that it's a bit of an anti-pattern, and I would sort of agree. And the reason I would agree is because, we'll come to it a little bit later with Flux, there's a different way that you should really be handling state. But this is kind of the typical top-down approach. So basically you have a parent, like I said, you might have your main app, which then has a console, which then has this button, and you pass that stuff down. And if you wanted to bubble the click all the way back up to the main app, you would have to explicitly do that via on-click handlers, right? But that obviously becomes pretty gnarly, especially if you get really, really deep. So don't do that. And that's why kind of Flux or like centralized data stores started to kind of play into this. Okay, any questions before I move on? I'm hoping I didn't gloss over too much here. Well, basically the main things that you need to worry about are, like, I would say the most common things are how components are created, the fact that they have a render method, the fact that you have get initial state and get default props, and that props and state are different. And basically inside of your component, you never mess with props. You just use them. You don't manipulate them. And then typically outside of your component, like any parent or anything that's interacting with your component, should only deal with props, and it shouldn't change the state. State should be reserved for only internal manipulation. Cool? Cool. Okay, so now Flux. Let's see, how are we doing for time? All right, I'm gonna try and cruise. All right, so Flux is also not a framework. And what is it? So it's not MVC. It draws inspiration from MVC. As you'll probably see a little bit. It also draws a bit from CQRS, if you're not familiar with that. It's basically an evented system for playing back data, being able to play data forward and reverse. And then FRP, which Kevin actually gave a good talk with a FRP library a few months back, I think in November, which is also online if you want to go check that out. So it doesn't provide models and collections. It doesn't make assumptions about the structure of your data. It doesn't make assumptions about where your data comes from. So it doesn't give you CRUD methods. It doesn't give you local storage stuff. It doesn't give you any of that. And it doesn't give you AJAX or WebSockets. Seems pretty useless. It's not. So what is it? It's an architectural pattern. And when I saw it, it's actually, to me, it reminded me a lot of kind of the mediator pattern, if you've ever seen it. And that's kind of what I've been using before with applications. You guys can go and look that up if you want. But basically, it's an architectural pattern. That's all you need to know. And it's an async event mechanism for passing data with a synchronous feel. So because JavaScript is async, I can tell you that even with mediator pattern, when you get a lot of events with a lot of listeners, and this is sort of some of the issues that happen with two-way binding or live binding to an object, when you have a bunch of listeners, it can get really hairy to figure out who's listening to what and when stuff's supposed to change, and did the changes get all applied yet, and what's the state of the object. All that stuff gets really hairy as a application pros. So the whole point of Flux is unidirectional data flow. And it also encourages immutability. So I'm throwing around big words, but what we're essentially saying is that your data shouldn't change, and that data should only flow in one way only. And the reason for doing that is so that it's easier for us as developers to wrap our head around something when it's happening, and so that when new people coming into an application, they can get up and running really quickly. When you have people leave an organization, you're not losing a ton of institutional knowledge, which happens all the time. So that you're following a consistent convention, which is kind of something we've been harping on a lot, and saying that the most important thing is writing consistent code. even if it's shitty, it's better to be shitty and consistent than it is to be writing good code but very inconsistent code. Because at least then, when you need to go and change it, it feels familiar. And so that's really what they're trying to do here. And it's really, there's the trade-off of verbosity a bit. I mean, it's not terrible, but it's not great for readability and easy understanding. So like I said, core concept, data flows in one direction. That's one direction. So high level, this is what Flux looks like. So we've already seen that we've got components, and I should have changed that. Sorry, this is view or component. But basically we have kind of four key pieces. So we've got a server, we've got an action, a dispatcher, a store, and then a view. And the way that data flows, you can see it flows one direction, right? 1D. And actions can be triggered either from the view, from the user UI, or from the server itself. Or potentially other libraries coming in. Like you could have, some other widget that's interacting with your site that is not your own component.
Does that mean that all of your event listening is handled by the dispatcher?
Yeah, yes. We're gonna go one deeper. So a little bit more detail. The way this stuff is structured, basically you've got, like I said, you still have the same things. You got your dispatcher, you've got your store, you've got your component, and then you've got action creators. So this is super, this makes sense to me because I have seen the code and played with it. So we're gonna maybe kind of flip back and forth. But basically, again, same deal, unidirectional. Kind of what I want to highlight here, I guess, is that almost all of this, even though it's evented and it's asynchronous, it's actually kind of forced to be synchronous. Like the way you look at it in code, it all looks synchronous. The only part that looks async, where you're actually doing AJAX requests or WebSocket listening, all that stuff happens here on the client-side API. So it's sequestered away from your application, essentially. It makes it a lot easier to test your app. It makes it a lot easier to switch out endpoints. It makes it a lot easier to change where your data is coming from, how it's structured. It's really, I think it's pretty smart to actually put that in basically its own almost little sandbox that's kind of segregated. And that doesn't impact any of this flow or any of the way that these components interact.
Is there a question, like, is it one store per component, or like, can the configurations be a little bit more flexible?
Sorry, I'm gonna finish my beer while it's getting warm. So the question was, is it one store per component, or can you mix it up? So it's definitely not necessarily one store per component. This is something that I think there's still some best practices emerging, and there's an interesting thing because Facebook actually put out something called Relay. I don't know if anybody had heard of it. I'm actually not even gonna really talk about it because I don't understand it yet. I haven't spent any time really looking at it. Essentially, it's trying to, yet again, put your data that your component cares about and how it fetches data inside of that component. So really trying to make everything completely self-contained. Yeah, I think that's something that maybe we'll leave for another talk. But essentially, like for stores, some of the patterns are kind of emerging. I would say it's definitely not one-to-one. In fact, most of the time, which we'll kind of see in one of the examples, you'll have multiple components listening to changes on the store because they're listening to them, but they care about it in a different context.
Isn't it just the word for one?
Yeah. Well, no.
No, you have to make up something different.
We're just gonna change the name. So it's not a model in the traditional sense, I think, in that where you have helper methods and you have all these sort of things. And I'll show it. We're kind of glossing over a lot. So let's go look at some code here. Close that guy. So there is, there's a pretty awesome GitHub repo this guy created. There's basically abstraction layers on top of Flux. And you'll see why. I'll come back to it. But this guy created a repo which compares a bunch of them, which is really awesome. We're only going to look at the Facebook Flux ones because that's kind of the default. That's like the underlying pattern. And my opinion is that the abstractions are nice because they take away some of the verbosity of Flux. But I think that that's actually taking away from what Facebook was kind of going after with Flux, in that sure it's verbose, or sure you might have more code than you need, or some stuff is really stupid, seems really stupid. But again, coming back to that whole rationale was keep things so that anybody can walk in and understand it basically from day one, just by reading that one file.
So there's always a thing. What if the designer walks in there?
Yeah, I mean,
I think that was always my biggest problem with this stuff. Because if a designer walks in there, the designer
and
have a very hard time.
To be fair, so
you have to like explain ES6 syntax to like somebody who's maybe used some jQuery.
Yeah, for sure. I mean, I don't have a great answer for that, honestly. I don't know. It'd probably be pretty crappy. I would say, like, when I was at Kissmetrics, the design team didn't really do a lot of that, and that was actually kind of a challenge for us. You know, we were doing stuff with React, but it's a big learning curve for people because, like, it's HTML, but not. I mean, in the one sense, I mean, you've got all your markup here, and you've got your classes, so like you can construct the markup in whatever classes you want. But in order to get some of the behavior or the animations that you might want, yeah, it's not quite as easy. And I think that's definitely something that to consider.
I think that's one of the clashes being fought out.
Yeah.
Next generation stuff.
Absolutely. But then on the other hand too, like I worked with some designers who are actually quite good, and then they pick up stuff really quick. So I think it depends a little bit on the personality of and the team that you have too. Sorry, where was I going with? Oh, basically the abstraction. So adding an abstraction on top of Flux, I think, takes away from what Facebook was going after. Because now, not only do you need to understand Flux as a new person, but you need to understand how the abstraction works. And it's also making sure that the developers didn't mess with how the abstraction works, right? Like, assuming they followed it perfectly, and assuming they followed Flux perfectly, right? So I think adding, I'm not saying not to do it, because I actually might do it on one of my apps as well, but I think you need to be kind of cognizant of that trade-off, in that you're adding extra overhead to anybody new that's coming on in their ramp-up time.
Some of those are actually rewrites, like ground up, as opposed to just building on top, like Reflux, for example.
Yeah.
It's just a complete redo.
Yep.
Revision.
Yeah, I mean, the one that I've been kind of liking the most is called Alt. It's ES6 style, but basically, I like the fact that it doesn't seem to have changed a lot of the underlying stuff. But anyway, I didn't want to go too far down that rabbit hole because I wanted to show kind of how Flux itself works. So if we look at the folder structure here, again, a little bit daunting, right? We've got actions, we've got components, we've got constants, dispatcher, stores, and then some utils. So if we go back, I'm actually going to pop this out and let's try and see if we can look at these couple side to side here. Barely. All right, so, I mean, what we've got here, you can see we've got actions and we've got our action creators. And so what actions are here is they're actually just strings. So actions themselves are just strings. That's it. The action creators or like what this looks like. So they're basically, they define a method, descriptive method. You find most of the stuff in React and in Flux are fairly descriptive. Again, maybe a bit verbose, but erring on the side of readability. And all they're doing is basically saying to the dispatcher, apply this action, right? And pass some values. Did you have a question, Kevin? Okay. So really straightforward APIs, but basically super simple, small method. And this is something that we'll show you where the action creator gets called from. So the action creators are either going to get called from the UI, typically from the UI, or potentially from data coming in from your server or from some third-party interaction. So we'll work around from actions and then kind of take a look at the API stuff. So from actions, we actually then move on to the dispatcher. And so what does the dispatcher do? It doesn't do anything all that special either. It basically just handles the call and then dispatches an event. Nothing too special. It's just basically an event emitter. The one thing that a dispatcher does is that, and actually I'm going to come back to that too, I'm not going to step too far forward yet. So you'll notice one of the things that we have here is we are requiring our constants, right? We've got our payload sources, and then we reference our payload sources, so view action. So we handle view action, and the source is view action. And so what does that even mean? So if we look at our constants here, we've got two groups. We've got action types, and then payload sources, which is what we were looking at, and we've got view action. And so what this module does, sometimes I don't even use it, it's called key mirror. Basically what it does is does this here, just to say like view action is view action. And these are actually, sets them up as strings like that. So basically, so you don't, to save you a couple keystrokes. But this is basically just a constant string that gets passed around. So then if we go to, back to our diagram, take a look. So we've got action listeners in our store that listen for messages that were sent by the dispatcher. And one thing to note actually is that the dispatcher is a singleton. So every store has a reference to dispatcher, so singleton being one instance, right? And action creators only talk to one dispatcher. So this is why I think it's kind of similar to the mediator pattern, because you basically have one centralized thing that's kind of sending events, receiving event requests and sending events out. And so the nice thing with that, and why it's kind of similar to CQRS or event playback, is that you can actually just, in one spot, start logging events, and you can log them somewhere and you could replay them, right? So you don't have to worry about logging them in a bunch of different locations. It's one centralized spot. Every message goes through there. All right, so now if we were to look at stores, so let's look at, maybe actually to give you a bit of a concept of what the hell we're even looking at visually. So basically we're looking at this. We're looking at a cart. We're looking at a shopping cart example. So when I add stuff to the cart, adds it to the checkout, I can check out, I paid, right? I can add stuff to the cart, sold out. If I add a bunch of stuff, my stuff goes up, my total goes up, shows me what I've got, and I can check out, right? So nothing too fancy, but kind of just showing how this stuff works through Flux. We've got a cart store and a product store, which we saw here, right? So the cart store stores our stuff here. We've got a product store, list of products that are available. So we go and jump into the cart store, and this is kind of where I think it's a little bit different than a model, for example. And actually, now I'm almost putting a foot in my mouth because this has little helpers like get total. But basically, what a cart store is it's also just an event emitter. It just listens for events. And typically you have some private methods, like you end up storing this in just an object in memory. You could start to shove that in local storage, or you could but that's actually better suited for the API, the client-side API of things. The one thing I think that would be sort of a concern is like what happens if you had a shit ton of stuff in here taking up a lot of memory. I don't know. I could see that being an issue. But basically what we're doing here is we're setting up our cart store, which basically emits, we got a couple of these helper methods, right? Which we'll touch on a little bit later. We can emit change events when this thing changes. We've got methods to set up and remove change listeners, so our change handlers. That gets set up in here, right? So our components have change events and store queries. And so we're able to register change events, and then here are our store queries like get total and get added products. And so then this is where the actual listening for events happens within the store. So we're going to the dispatcher, and we basically have this pretty gnarly, and this is the thing that people get scared of, because we've always been told that case statements, switch statements are terrible things. And this can get a little gross. And this is what a lot of the abstractions or implementations of Flux takes away. I would agree that there's a better way to do this, but on the other hand too, I can understand why they did it in terms of readability, right? You can go in right away and see. And what I've seen so far is that most of these switch statements don't end up being that big. And by that big, I mean like no more than 10, let's say 10 statements, because typically it's probably a concern for another store if you're listening to other weird stuff. So most of the time, like this cart shouldn't be probably listening for a bunch of other weird events that, like, then you might need to rethink that you're probably doing something kind of strange. But essentially the events that we're listening for here are like our same constants, right? Add to cart, which we look in here, add to cart, right? Cart checkout, success checkout, and that's it. And so when that stuff happens, so this is kind of one of the things that is special about the dispatcher is we have a wait for. And so another thing that was kind of weird for me is that with Flux and Facebook's dispatcher is what they do to prevent race conditions, because when you have a bunch of events happening, you can end up with some events coming through at different times. So they actually, right here, you'll notice when we do app dispatcher, when we register our callback function with the dispatcher, we get a token, a unique token that's returned to this store. And what we do is if we need to wait for something else, because Flux will make sure that you can't dispatch more than one event at a time, which again seems a little weird. You have to wait for, if you're dependent on something, basically if two stores are listening for more than one event, you have to determine which order you want them to listen to that event, how you want to respond to that. And the reason being, so because things can only really happen in some sequence, there isn't really a performance penalty to it, and this prevents race conditions from happening. So it's a really, really nice, seemed kind of weird to me at first, but it's actually a really nice side effect, a really nice feature, I'd say. And then the only thing that we're doing is basically like we've added a product to the cart. We waited to make sure that the product store, to say that if we look at the product store, we've got a add to cart. So we basically are making sure that the inventory was decreased first before we actually add it to our checkout, right? Which makes sense. And then all we're doing is adding it to our own internal object of products, our own private object, and emitting an event to say something changed. So it looks like a lot of stuff, but it's actually not pretty simple mechanism. Any questions so far? This stuff took me kind of a bit to kind of wrap my head around. Okay, cool. All right, so the next thing that we'll look at, and then I actually won't be too much longer. So the next thing we'll look at is the React component itself. And so these are any of our actual components. So let's just look at the cart container, for example. So what we're doing, we saw that we can do get initial state. So what we've got is we've got a little helper method here that will return the state from our cart store by calling those helper methods to get the added products, right? So all the products that are in our cart, and get the total. Oops. And basically we're going to return that and set it as our initial state for this component, right? Then basically what we do as part of our lifecycle method is we say when we mount it, we add a change listener. When we're going to get unmounted, we remove. Make sure we remove that change listener. And then we've got a little helper method that says like, hey, when we checked out, so here we see like our products, we list them out. We've got our total, which is calculated. And then when we click the checkout button, we're going to call our checkout clicked method, and we're basically going to say send an event to our action creator to say that we checked out, right? And if we were to go back and look at that, what does that look like? Checkout, send a cart checkout message, nothing special. And then I think our cart store, so that'll go through the dispatcher, and then our cart store has a cart checkout, and basically we emit a change event, and we're gonna probably go through another cycle where we get a success event, and then we print out something to the console. All right, so the last piece of this puzzle is the client-side API. And this is typically where you would interact with your with the server or with any other third-party libraries. That's where all of your async stuff happens. Now, with this example, they're just doing everything client-side, local storage. So it's not great, but they actually simulate network latency. But basically here is the only place that we require our web API utils. And on checkout, we call this method checkout products. So that was what happens when we click our checkout button. We're going to call checkout products. We've got a nice little shop thing here that basically says we're going to buy stuff, and we got some timeout. So this is simulating your kind of network request to a server, right? Assuming that came back positive and we're A-okay, we purchased our stuff correctly. In our action creator, we're going to call finish checkout, which then calls the cart and says success. And we went and we bought all those items. So it may seem a little bit crazy at first, like there's a lot of overhead and there's a lot of stuff happening, but I hope that this actually shows that when stuff, because it's always following that same flow, it's very easy to debug stuff. It's also very easy to test stuff, and it's very easy to log, because you only need to log stuff in the action creators. And really, you only need to write tests for your stores, for some of your store methods, and for some of your API methods. Because all of this stuff is basically just proxying events to certain things and trying to make it a little bit more verbose and more clear to the developer as to what events are going where and to who. So we already talked about abstractions. We already kind of put it together, so I walked through all that stuff. Let's talk a little bit about some of the pros and cons, and then we'll wrap this up. So some of the pros that I've seen are like, it's very performant. It's probably one of the most performant things if you're not totally messing stuff up. Basically, if you follow Flux and React and you're not doing like insane loops inside of your render functions, or well, sometimes you can even get away with insane loops, which is bad. But if you're not doing insane loops in there, or you're not doing, even with large amounts of data, it's just super quick. So generally stuff renders in around 16 milliseconds. And there's some great articles, one that I linked here that basically that reduces web jank. So the idea that stuff isn't gonna jump around on you when you render stuff. Another huge pro for me, especially after doing a bit of work with Angular, was error messages. Like the error messaging in React is so good. It's the best I've ever worked with. It shows you exactly where, especially with the React Chrome plugin, it shows you exactly where stuff, where the error occurred. It gives you a very descriptive error message, and when you actually use prop types, it'll tell you when you're right away. It'll give you warnings that you're not passing the right information to your component. Another thing that they go with is learn once, write anywhere, and that's the idea now being applied to React Native, where that you can write, in theory, you could write a lot of the same components, a lot of the Vue stack, and actually use that stuff on mobile and like on iOS and soon to be Android. And in theory, yes. In practice, almost yes. Most of the time it's pretty good, but people are having to write adapters, and I mean, you have to write adapters to talk like native iOS bindings. For example, not everything is there. Like they didn't build every possible thing that you can do on iOS. They built a lot of the basic stuff, and it's coming along really, really fast. But the way that like the underlying JS, I think at some point there will be an abstraction layer that kind of helps you switch between the iOS version or Android version and the actual JavaScript version, because some of the API calls just aren't the same, or you might be expecting different data. But the concept is at least the patterns are the same, and at least the code syntax is the same, right? So it at least feels very familiar, even if you've never written iOS before. It's easy to understand, it reduces weird side effects, race conditions when you're using Flux, really easy to test, and it's predictable, right? So cons, it could be smaller. Right now it's 121K minified. I think that's even down from 140, so they're trimming stuff out.
Sorry, can I just make a quick comment about the testing?
Yeah.
So you talked about testing like the store and stuff like that, but actually it's also very easy to test the views themselves. Facebook has this
Jest library,
which allows you to instantiate your views using their virtual DOM, so you can actually test them using Node or whatever.
Yeah.
You don't actually have a real browser to test your views. And you can actually simulate clicks on like buttons.
And that's one of the beauties of the virtual DOM too. So basically, what Kevin was saying is that you don't have to have a browser, like with Jest especially. You don't have to have a browser to actually test the components, and that's part of the nature of it being virtual DOM too, because you're able to test all of the event bubbling and everything, all the event stuff in with virtual DOM. Yeah, I've found the components are super easy to test, but one of the things that I kind of mentioned a little later is that it's really, I think it's kind of a con that you actually need to compile or transpile to test. I think, I haven't actually used Jest, to be fair. I've actually done testing with Mocha and stuff, and Jasmine and Chai, but not with Jest, and so I'm not sure with Jest if it handles the transpiling for you or not.
I can't say because I didn't actually
set up the testing. But basically, I mean, the JSX needs to be converted to JavaScript, right? So at some point that needs to happen, which kind of sucks when you're testing, especially as the app gets a bit bigger. Like I said, Flux is a bit verbose. One of the big things, it's changing a little bit now, but having to reinvent the wheel. So React Rocks, .rocks has a bunch of libraries or modules that people have written. There's another one called, so well, if you're looking for native stuff, there's React.parts. And then React Components is the other one. It's coming along. The people are doing wrappers for other existing libraries, but it's still a little bit clunky when it's not a true React component that somebody has written. I find it's a little bit weird to integrate. And sometimes it can be a bit funny. Most of the time, it's actually much easier to re-implement it in React, which is kind of why it's been happening.
To get GitHub stars too, eh?
Yeah, best way to get GitHub stars, yeah.
React slide in, React.
Yeah.
Date picker, React Bootstrap date picker.
Yeah, I mean, there's stuff that's coming along. Like there's a material UI one, there's Bootstrap ones now. So, I mean, it's coming along, but when I started working with it at Kissmetrics 9-10 months ago, I mean, we were rolling all our own stuff because there was nothing out there, which is kind of shitty. But on the other hand, too, we were able, even though we were having to do that, we were still able to get it out pretty quick, which I think is kind of a testament to the way that the components are written. So some quick tips, basically keep your components small if you can. Ideally, that's better. Attributes are camel case, which kind of sometimes I forget that, especially since I'm using something that autofills my stuff and not through React. Put computed data calculations inside render or helper functions. With Flux, you saw that the total was getting computed in the store. That is a better solution. When you're not using Flux, you're better off to have those methods inside of render. So let's say you wanted to calculate a currency, for example. You probably should just put the value in currency or in dollars and do that inside of your render method. It's actually not that expensive. And then it's always managed by React. Some people have had a habit of putting it on properties on the component. You shouldn't do that. You shouldn't set the state if you don't need to and you're just using it for rendering and not for other things. You shouldn't set the state, like say the currency. The currency wouldn't belong on the state. It just should be a variable in the render method or a helper method that is called from render. If your component has a lot of helper methods, I've seen components just like blow up because there's so many different render helper methods where you're rendering little separate sections. Just split them into separate components or separate modules like helper libs. I might get some hate from this, but don't use backbone models or collections. You don't need them. I don't think you need them. And the reason you don't is because it's just another level of adding those extra get calls to get at your actual attributes. And having that extra event mechanism bloats your application, but also makes it harder to access your data because it's one more call you need to make when you actually get the model in your view, or when you get that data in your view. Or you're doing it on the store and you may as well just have the raw object on the store anyway. Because the way that Facebook has been kind of promoting stuff is immutable JavaScript. So the idea being that your JS doesn't change, it just gets replaced all the time with new stuff. Right? So a couple more. If a component needs to let other components know about its state, so we saw the second button, like the toggle button. We had a callback for a click handler. Especially when you're using Flux, that should probably just go to a store. So you should probably just be firing an action to update the store, even if it's a global app state store, to say like for example, and this is something I wrestled with for a while actually, for example, having a modal open. So you might have a modal that opens and then want to close the modal, or after you maybe are saving a user profile or logging in, and after they've logged in successfully, you want to close the modal. Well, doing that back through sometimes a convoluted callback chain can be really gnarly, and instead you're better off having a global app state that says, hey, this specific modal is open, or even just a modal is open, but firing a second event to say close that modal once the action was successful, or maybe not. Right? Autocomplete and autofocus on forms are a bit clunky, especially if you're using third-party libraries to autofocus. You might need to put set timeouts in your component did mount. I've actually found that too using Velocity.js, which is an animation library. React has its own animations, but those are like, I found them super hard to work with actually. And Velocity allows you to animate SVGs, which is nice too, on top of animating just DOM. The downside to it is because it's not React and it's kind of a jQuery plugin, is that sometimes your component isn't actually rendered before the component did melt part is happening if you've got an animation applying to it. So you actually need to set a timeout for the time period of the animation. It's kind of a little quirk that took me a while to figure out. And then React actually can render and animate SVGs now, but it doesn't support all of the attributes, and that's something that is coming, but I'll be pretty excited when some of the more advanced attributes come in, because you can, because of the performance of state and how React manages the lifecycle, animating SVGs are super easy with React. And I think that is it. So before I take questions quickly, next month we actually switched with YYC Ruby. So we're gonna, yeah, just for the next 2 months. So June 2nd is gonna be the next meetup. We're gonna have a special guest presenting. We're not sure what he's gonna talk about yet, so it'll be a surprise. But he's from Dallas JS and a colleague of David's. So he's coming in and is gonna give a good talk. And then we actually have a brief intro to Ethereum, which I had never heard of before, right? So Derek's gonna give a talk, and then, or a quick intro, like you're saying roughly 5 minutes?
5 minutes.
Cool. And then sadly, July 7th, we also switch with Ruby, which isn't the sad part, but Dave's gonna be heading to Vancouver. So post July, I think we'll definitely be taking a break in August, and then we'll kind of regroup and see what we wanna do, because I'm gonna miss Dave. But any questions? If people need to bounce, feel free. Christian.
Can you show the quote plugin?
Yes. Let me. Of course, I probably don't have it in because I was doing some Angular stuff. So no, I cannot show you. Yeah, it's not too crazy. It basically just shows the JSX in, like you have the ability to inspect the JSX. So it's kind of like a source map. Yeah, it's like a source map.
Does it also have like a view of its components, like its view of its own DOM? So like when you have like a cart button or whatever, like it shows up as a cart button.
Yeah, it shows some additional stuff like what the virtual DOM looks like. I think it even shows some of the performance, some performance numbers around it. Honestly, I haven't gotten all that crazy with it. It's just nice to be able to see the JSX there, because at least, you know, what I've been finding, as soon as I started splitting up my stuff into templates a while back, is that sometimes getting a view of what your whole DOM structure looks like, keeping it all in your head, at least for me, can be a bit tricky. So it's nice to be able to see not only the DOM, but then also the JSX structure. But it's essentially source map. I actually found it a little bit flaky sometimes though, in terms of it just not showing up. But other than that, it works great. Any other questions?
Do you have to use Flux?
No, you do not have to use Flux. You do not at all.
So that example you showed, like without Flux,
yeah, so what I've seen, I'd recommend Flux. And don't get me wrong, I was so confused. Like, I was like, whoa, what is...
There's the whole anti-Flux movement.
Yeah, yeah.
So...
having worked in 3 apps now, to be fair, 2 of them have been smaller. One of them is one that I'm working on, and it's getting bigger, and I'm using Flux. I decided to move to Flux to manage the data because I'm building a native like a cross-platform desktop application. It's basically an actually nice database GUI that works and looks good. But when we were at Kissmetrics, I think like I kind of, not to knock it, but I think when I was there, we weren't using Flux and we were using backbone models, and just we had view controllers, or we were kind of following an MVVM pattern, and it became pretty complex to figure out where data was coming from pretty quickly. Like, we were able to bang out components super quick, and the components themselves were well written and really small, like especially the small components. But I would say what we had as view controllers, they became pretty bloated because, and we just, this gives you a nice framework for where you should be fetching your data. And I think that was a big thing for me, is that if we go back really quick to the diagram, like isolating your client-side stuff, or like your server-side interaction, to one spot, or basically a set of files, and that only, is really nice, rather than having them littered through potentially view controllers or potentially through all your models. And I think that was a big thing for me. You can totally do it without. Some people, I think this is a terrible idea, but some people fetch stuff in their component did mount or component will mount, and they'll go and do an AJAX request. I think that was one of the initial examples of how Facebook had it. Their quick and dirty example was like, hey, do the AJAX call and component will mount. Well, that's not all that scalable, and it bloats your code quite a bit. Makes it a lot harder to test too, that individual component, the view part. I think at a minimum it should be outside, and all your components should be feeding. You should be feeding data via props to your components, ideally as much as possible, and then try and keep a lot of the fetching and formatting in a separate model or API layer, even if you're not using Flux. I don't know, from experience, like the mediator pattern, or essentially having a central dispatcher of some sort, I think is a huge advantage, because at least then you've got one place to log when you're unsure of where stuff is coming from. And you have one place where it's really easy to be able to see who's listening to what and what's going where. Because as an application gets bigger, that can get really hard to figure out.
So really also the flow, to control the flow of data, like you said?
Yeah, I think so. Like the way that I used to build apps, I don't have it. The way that I used to build apps was basically having a central dispatcher, and this was before React, and kind of following Backbone Aura. I don't know if you'd ever seen that before, but basically having a central event hub, kind of like PubSub, and then having a bunch of separate components that only deal with their own stuff. So I might have like a nav bar, and I might have a modal component, and they only listen. They might listen for the same events, so it's kind of similar to this, right? But they only care about that event within a certain context. But I think having that central pipe where data could flow both ways, as we added more components, it became really hard to figure out which data was going where and in which order. And them forcing it to go in a synchronous order, and even in your store saying like, I'm waiting for this other store to update first, makes it a lot easier to follow. Anyone else? Sorry, a little bit long, but hopefully that gave a good overview. And maybe later in the year we'll show some other stuff with Feathers and how you can integrate that with React and get real-time stuff happening. Cool? All right. Thank you, everyone.